Good afternoon to all the EAPCET aspirants. This is your Prasanna ma'am from NEET World, and here we are in our last concept session from the chapter Morphology of Flowering Plants, and that is morphological families, wherein from EAPCET syllabus we have to deal with three families in major beta, that is Fabaceae, Solanaceae and Brassicaceae, okay, which includes Fabaceae, Solanaceae, Liliaceae and Brassicaceae. So, to the students who are first time looking into the chapter Morphology of Flowering Plants, my advice to you is, first you go as per the content that is given in the text beta, like as such. First, vegetative characteristic, root, stem, leaf, its characteristics and modifications, and then floral characteristics, and then families, okay. But then to the students who are in long term or who are going with the revision of this chapter, to all of them I advise you to finish first families. You finish beta. First set you have to finish is families. In families also, how you have to start your preparation? First you should know the semi-technical description, fine. First you have to be aware of the semi-technical description, and then you have to go with floral diagram and floral formulae, okay, floral diagram and formulae, fine. And then you have to go with floral diagram, formulae, and then you have to go with the examples. Just completing of the distribution, vegetative characteristics and floral characteristics with the examples, 60% of the chapter will be done beta. If you are done with distribution, vegetative characters, floral characters of the families with the examples, 60% of the chapter is done, and after completing families you then go to floral characters and then vegetative characters if you are in the revision of this chapter. If first time you are looking into the chapter, then go with the flow, same flow, like first vegetative characteristics, root, stem, leaf characteristics and modifications, then floral characteristics and then families. That should be the flow if it is first time. If it is your second time or revision, then the first thing you have to do is finish off the families with the examples, okay, and then go to floral characters and then go to vegetative characteristics of the chapter. Now, without much delay, let us get started with the semi-technical description first, ma'am. Semi-technical description, here you see BR, which means bracteate, EBR means ebracteate. First you have to know what is meant by bracteate and bracteolate. So, here when we have to look the main stalk which is holding the entire inflorescence, this is called as what? Peduncle, right ma'am? Peduncle is the main stalk which is holding the entire inflorescence, and the small stalks which are holding the florets, these are called as what beta? Pedicels, right? These are called as pedicels, and peduncle. So, here you see the small bract-like structures which are present below the pedicels are called as bracteolate, okay, and small bract-like structures which are present at the peduncle region is called as bracteate. If bracteate is present, it is called as bracteate. If the bract is absent at the peduncle region, it is called as ebracteate. If the bracts are absent in the pedicel region, those are ebracteolate. If these bracts are present at the pedicel region, those are bracteolate. And this symbol indicates actinomorphic. Actinomorphic means which follows what type of symmetry beta? Radial symmetry, means by any plane you can divide the flower into two equal halves. And then this symbol indicates zygomorphic, whereby a single plane you can divide the flower into two equal halves. And then this indicates male flower, female flower and bisexual flower. K indicates calyx, C corolla and P perianth, where indistinct calyx and corolla is there. Like calyx and corolla will not appear as two words, they will appear as a single word, and that is perianth, which you will observe in Liliaceae family. A is for androecium, G gynoecium, and if the hyphen is below the G, it indicates superior ovary. Okay, if it is subscript, this is indicating what? Superior ovary. If hyphen is above G, that is superscript. If it is above G, it indicates what? Inferior ovary. Hyphen below G, superior ovary, indicates what flower beta? Hypogynous flower. Hypogynous flower. Hyphen above G indicates inferior ovary. What type of flower, ma? This indicates hypogynous flower, and this indicates epigynous flower. Epigynous flower. And how will you indicate half inferior, half superior ovary, ma? Like this. Okay, half inferior, half superior ovary, that indicates perigynous flower. So, this is the semi-technical description that we follow to write a floral formula. Okay, how a flower is present in each family, that floral formula will follow this semi-technical description. Here you look at these 2 points. A floral diagram provides complete information about number of parts of a flower, their arrangement and their relationship with one another, that is its relationship with one other world. Okay, what is the information that you are getting from a floral formula and from floral diagram is very important, where we can expect a statement based question from this. Like what information that you will get from a floral diagram, you have to remember, you will get the information of number of parts of the flower or number of whorls present in the flower, how they are arranged, like aestivation, placentation you will get to know, and then what is the relationship between the different whorls present in that family. And then floral formula. What does floral formula indicate? Floral formula also shows you about cohesion and adhesion within the parts of the whorl, like how the whorls are present, like cohesion, whether they are showing gamosepalous condition, gamopetalous condition or polysepalous, polypetalous condition, whether they are indicating how many bundles of stamens, monodalphous, diadelphous or polyadelphous condition. Is there any adhesion, like androecium attached to petals, epipetalous condition is present or not, epiphyllous condition is there or not, or syngenaceous condition is present or not. This and all will be indicated by floral formula of the whorls or between the whorls. Cohesion and adhesion of whorls or between the whorls is indicated by floral formula. So, from this slide what you have to be clear with beta, the semi-technical description that is followed, and the second thing is what is the information that you can get from floral diagram and floral formula. Till here it is clear, right ma? Yeah. Here you see, first if we finish off floral diagram with floral formula, then entire floral characteristics of that particular family will be in our mind. Okay, look at here. First, see here beta, the outer whorl indicates calyx. Next whorl to calyx is corolla. Okay, and then it indicates androecium. This one will indicate gynoecium. If you look into Fabaceae family, Fabaceae which is previously kept in Papilionoideae family, which is under the subfamily Leguminosae by Bentham and Hooker classification. As of now, we will learn it under what? Fabaceae, where we will use Leguminosae family as a synonym to it. Look at here, the outermost whorl is what? Calyx. Here itself in the floral diagram, you can clearly see how the sepals are arranged. They are attached to one another, but you cannot see any overlapping between them, right? They are just attached to one another. This type of sepals arrangement is called as valvate aestivation. This is calyx, which follows what aestivation beta? Valvate aestivation, and they are fused, which is showing gamosepalous condition. Next to that is corolla. Looking at this diagram itself, we can say this is following what aestivation? Vexillary aestivation, wherein there is one standard petal, two wing petals and two keel petals which are fused, right ma? One standard, two wing petals and two keel petals which are fused, which is following what aestivation? Vexillary aestivation, where we can write it as 1 plus 2 plus 2 fused. Okay, and androecium, if you see, androecium, total 10 androecium are present, you can count it, wherein they are arranged in two bundles which are showing cohesion. Androecium is showing what? Cohesion here. Stamens are showing what? Cohesion here, wherein 9 stamens are fused to a bundle and a single stamen is apart, which is 9 fused plus 1. This condition is said to be what beta? Diadelphous condition. Okay, diadelphous condition. diadelphous condition. And here you can see gynoecium, which is monocarpellary. Monocarpellary, single carpel, where ovary is superior as hyphen is below G. It indicates what? Superior ovary. Once again you look at the floral formula, it is bracteate and bracteolate for Fabaceae members beta. Bracteate, bracteolate. And then this symmetry is what? Zygomorphic symmetry, whereby only by a single plane you can divide the flower into two equal halves. Okay, which follows what type of symmetry? Bilateral symmetry. Okay, zygomorphic flower. And as both androecium and gynoecium are there, this indicates what? Bisexual flower. And here calyx is 5 fused, corolla 1 plus 2 plus 2 fused. Okay, androecium 9 fused plus 1. Fine, which indicates what type of androecium here? Diadelphous condition. And gynoecium is 1. Okay, which indicates what ovary? Superior ovary. Here you see beta, next family is Brassicaceae, which is also called as Cruciferae. Okay, here you see first the outer world, again it is calyx, next to that is corolla, and next to that is what? Androecium, and here at the center it is gynoecium. So calyx, here you see 2 whorls outer end and 2 whorls are present at the center. This is not showing, here overlapping is present, but it is not in a uniform direction. When it is not in a uniform direction, you cannot say it as a twisted aestivation, right? So 2 whorls outer side which are completely overlapping the other 2 whorls, where you will call it as what? Imbricate aestivation. This is imbricate aestivation, fine, where overlapping of whorls are there but not in a uniform direction. And next whorl to the calyx is what? Corolla, where they are attached to each other. Okay, attached to each other, but they are free. It is not gamopetalous condition. Polypetalous condition with valvate aestivation. Okay, so corolla is what? Valvate aestivation. Corolla is following valvate aestivation. Next to that, here you see androecium. Androecium, here in Brassicaceae members, stamens will be of varied length, okay, which shows tetradynamous condition, wherein 2 androecium filament length will be very long, other 4 will have short filament length. This is called as 2 plus 4 condition, which is showing, androecium is showing what ma? Tetradynamous condition. Tetradynamous condition. Few of the Brassicaceae members will also show diadynamous condition, but this is what? Tetradynamous condition. And at the center you have what? Carpels, okay, gynoecium, which is bicarpellary. This follows parietal placentation, wherein at the center septa will not be there, but septa is present as such. That shows as a false septa, which is called as what? Replum, which is a characteristic feature of Brassicaceae members. This is replum, false septa or replum is present at the center, which indicates as it is bicarpellary. Okay, so this is bicarpellary and has superior ovary as hyphen is below it. Look at the floral formula once more. This is E bracteate, actinomorphic, which means you can cleave the flower through any plane into 2 equal halves, which follows radial symmetry, and both androecium and gynoecium are there. So it is bisexual. Calyx 2 plus 2, which shows what aestivation? Imbricate aestivation. Corolla 4. Both are free condition only, polysepalous, polypetalous. And then androecium is 2 plus 4 condition, that is tetradynamous. And then gynoecium, here 2 fused, okay, which is bicarpellary and has what? Superior ovary. Clear with these 2 families beta? Clear with these 2 families? Yes, right? Fabaceae and Brassicaceae. Next you see Solanaceae members. In Solanaceae members, if you have to observe, the outer wall again it is what? Calyx. This is called as mother axis beta, which indicates posterior side of the flower. Okay, this is mother axis. Fine. This is calyx, this is corolla, androecium and gynoecium. So now you say me, calyx is having sepals which is gamosepalous or polysepalous. Gamosepalous, right, because in floral diagram it shows they are attached to each other, not overlapping, but they are attached to each other, which shows what aestivation? Valvate aestivation. Fine, this shows valvate aestivation. Corolla is also same, they are just attached to each other, petals are attached to each other which are fused. This shows again what? Valvate aestivation, gamopetalous condition. Here androecium is showing adhesion with the petals, yes or no ma? Androecium is showing adhesion with the petals. This is called as what condition? Epipetalous condition. Epipetalous condition. And then gynoecium at the center which is bicarpellary. So, here you see first calyx, calyx 5 fused, corolla 5 fused, androecium 5 which are free, and that shows epipetalous condition. Gynoecium, if you see, gynoecium is bicarpellary which has superior ovary. Clear, right? This is the floral formula. Fine, right ma? Next, Liliaceae, if you observe, they doesn't have calyx and corolla. Calyx and corolla is indistinct here and they are turned to what? Perianth. We call it as perianth. Perianth, if you see, they are fused condition 3 plus 3, okay, which follows imbricate aestivation. They are completely overlapping, but this is not in a uniform direction. So, here perianth is showing 3 plus 3 fused. Fine. This is outer world is what? Perianth. Outer world is perianth. Next to that is what? Androecium. Here you see androecium is showing adhesion with perianth. This condition is said to be epiphyllous condition. Fine ma. This is what condition? Epiphyllous condition. So, androecium is again 3 plus 3, but then they are not fused. This shows epiphyllous condition. And gynoecium, if you see, gynoecium, it is tricarpellary. Tricarpellary, again it has superior ovary. And if you take bracteate and bracteolate, both has both bracteate and bracteolate. Fine, right? This is the floral formula of Solanaceae and Liliaceae. I hope this is clear. So, my words, remember carefully Vita, if you can clearly understand floral diagram and floral formula of these 4 families, then 90% of the characteristics of families are in your hands. And at last you just remember the examples of each family, then you are done Vita. So, here you see first Fabaceae, the characteristic feature that you have to remember from Fabaceae members floral diagram is diadelphous condition. And Brassicaceae members, this shows cruciform corolla, that is the characteristic feature, that is why it is also termed as cruciferae. Okay, characteristic feature here is cruciform corolla. Cruciform corolla, which is present like this, cruciform corolla, okay, in X shape, okay. This is the characteristic feature of Brassicaceae members. Second is about androecium, that is tetradynamous condition of the androecium. In few of the flowers of Brassicaceae members, diadynamous condition is also observed. Next is Solanaceae members, characteristic feature you have to remember is epipetalous condition Vita, and then Liliaceae, epiphyllous condition is characteristic, okay. So, these are the characteristic features that you have to remember from 4 families, floral diagram and floral formula, fix it in your mind. And next here we see comparative analysis of first Fabaceae, Solanaceae and Liliaceae, and we will learn Brassicaceae as key points later, okay. We will first learn the comparative analysis of these 3 families. Just for 1 minute go through the floral diagram and floral formula ma. If you are having any doubt, just ask me, just a minute. Here we go, okay. First, what are the common names for these families? Fabaceae is also known as Leguminosae or pea or bean family. Leguminosae, pea or bean family. Previously, this is placed under Papilionoidae. Under the subfamily, Leguminosae. by Bentham and Hooker classification. Bentham and Hooker classification. Fine, right. Next, Solanaceae, if you see, potato, brinjal and tobacco family, also known as commonly. Liliaceae is commonly known as lily family. If you see distribution, Fabaceae members are worldwide distributed, mostly in the tropical and subtropical region, mesophytic habitat, in mesophytic habitat. Next, Solanaceae members, they are widely present in tropics and subtropics, especially in the temperate regions, and they are mesophytes here. Next, Liliaceae members are also cosmopolitan in distribution. They are mostly present in temperate regions. Here you see Fabaceae members, tropical and subtropical mostly. Here tropics, subtropics and temperate regions. Here mostly in the temperate regions. This includes mesophytes like allium, lilium and xerophytes like aloe vera and asparagus. Fine. Approximate diversity of these members. Here you see Fabaceae members, approximate diversity is 450 genera, 8500 species. Okay. Solanaceae members, they are present across 85 genera and in and around 2200 species. And highest members, Liliaceae members, highest genera you can say 254 genera and species 4075 species. You need not to remember the exact number, but at least remember the approximate number to identify in between the options. I hope the diversity or distribution is clear with respect to these three families. Next we will move on to the vegetative characteristics. Vegetative characteristics where we have to highlight the modifications beta. Highlight the modifications like which family is showing what type of root modification or type of stem modification or leaf modification as such. Highlight the modifications and go through the vegetative characteristics of the families. First you see the habitat of Fabaceae members, they are mostly herbs, mostly herbs. Some shrubs will be there, some climbers like Pisum sativum or some other members like tendrils will be present most commonly. And Solanaceae members mostly herbs, some shrubs will be present. And here in Liliaceae members mostly perennial herbs they are. Okay, which live for many years, perennial herbs, especially underground stem modifications. Liliaceae though immediately you have to remember underground stem modifications like bulb, corm and rhizome. Few shrubs and climbers also will be there like smilax and gloriosa. These are few shrubs and climbers. Next, root system, here you see taproot system with nodules are present, with nodules like rhizobium, taproot system with rhizobium, which forms what? Root nodules for nitrogen fixation. Okay, for nitrogen fixation. This is the root modification that you have to remember with respect to Fabaceae members. Rhizobium, which is a gram-negative bacteria which is in symbiotic association with the roots of Fabaceae members or leguminosae members. Okay, which we will call it as legume roots. The main purpose of this association is what? Nitrogen fixation. Highly important characteristic feature, remember. Next, Solanaceae taproot. Here in Liliaceae members, the type of root modification you have to remember is adventitious roots mostly and fasciculated tuberous roots, storage root modification of asparagus. Okay, storage root modification for Liliaceae members. Remembered, right? Next, stem, if you see aerial, climbing, prostrate or erect, woody, herbaceous stem in Fabaceae, and here Solanaceae majorly you have to remember is, this is the common characteristics you will have anyhow in many of the Solanaceae members like aerial, erect, cylindrical, hollow or solid, hairy or glabrous type of stem, and the modification here you have to remember and highlight is underground stem tuber modification. Okay, underground stem tuber modification in potato which has bicollateral vascular bundles. This thing to highlighted important, you have to remember storage underground stem modification, underground stem modification, that is storage stem, fine, that is stem tuber. Here in Liliaceae members under stem modifications you have to remember underground bulbs like alum cipa, corms, colchicum, rhizomes, gloriosa, aerial weak stems and climbers are present. So, bulb, culm, rhizome with the example of this family you have to remember. Okay. Next is about leaves. Okay. Leaves you see alternate, stipulate, pinnately compound, reticulate venation type of leaves are present. Okay. Here in Solanaceae members it is alternate, exstipulate, okay, exstipulate, simple or pinnately compound, reticulate venation, petiole often it is adnate to the stem. Okay. Exstipulate simple and petiole is often adnate attached to the stem. Here you have to highlight the exstipulate condition. Clear, right ma? Next in Liliaceae members you observe this is mostly radical, simple, linear, mostly it follows parallel venation only. There is one exception that you have to remember is in Smilax this shows reticulate venation. Okay, Smilax it shows reticulate venation and mostly this is often exstipulate condition. So, from this entire table what you have to highlight and focus is root, stem and leaf modification wherever it is required. First in roots if you take root nodules that you have to remember with respect to legume roots, that is Fabaceae members. This though you have to remember. Next, adventitious or tuberous root, storage root modification in asparagus of Liliaceae. Clear, right? Next, stem if you see underground stem tuber modification in Solanaceae, underground bulbs, culm and rhizome you observe it in Liliaceae members. Thirdly, leaf, stipulate and exstipulate conditions should be highlighted. Most importantly, the Smilax which is an exceptional case which follows reticulate venation in Liliaceae members should be remembered. These are the things that you have to pay an additional focus and remember modification specially from vegetative. Floral characters, the entire table is important, and to remember floral characters you need not to take extra stress and all. If you remember floral diagram and floral formulae, then all these floral characters are yours ma. So, here you see once again inflorescence. What type of inflorescence you see in Fabaceae members? Mostly it is raceme type of inflorescence. Solanaceae members will follow cymose type of inflorescence, like it can be axillary cyme, solitary cyme, terminal or panicle type. Next, with the examples you have to remember, like axillary you see in Solanum, solitary or terminal cyme in Datura, panicle type in tobacco. Next, Liliaceae members, solitary cyme you will observe, umbel or raceme. Three types of inflorescence are possible. Okay. So, this is about the inflorescence of three families. Next is flower. Flower you see in Fabaceae members, it is bracteate, zygomorphic that we have seen in the floral diagram, and it is a complete flower. What do you mean by a complete flower? A complete flower consists of two essential, two non-essential whorls. Okay. It has 4 whorls in total. It is a complete flower and it is bisexual. It has papillonaceous corolla and it shows superior ovary, that is hypogynous condition. Solanaceae members you see bracteate, ebracteate any condition, actinomorphic is its symmetry we have observed in floral diagram, complete flower again, bisexual and hypogynous. In Liliaceae you observe bracteate, ebracteolate, actinomorphic which follows radial symmetry, bisexual or sometimes unisexual. Unisexual again you have to remember the examples, that is Smilax and Druscus. Trimerous, okay, trimerous means it has 3 perianth or multiples of 3, 3 plus 3, and it shows what type of flower? Hypogynous flower. 3 flowers are hypogynous only, you remember that. So, with flower and inflorescence you are clear no ma? With flower and inflorescence. Now, you see calyx. Calyx, 5 calyx are present. Gamosepalous in Fabaceae members, and it follows what aestivation? Mostly valvate aestivation. Sometimes it also follows in few of the flowers or genera, it also follows what? Imbricate aestivation. Next, Solanaceae members, 5 sepals are present which shows gamosepalous condition. This is persistent in Solanum and Capsicum. Persistent calyx is the characteristic feature of Solanaceae members. Remember that, okay? Persistent calyx, is the characteristic feature of what? Solanaceae members. And then Liliaceae 6 tepals 3 plus 3, and this shows valvate aestivation. Next is corolla. Corolla has again 5 petals, papilionaceous condition, standard wing, standard petals, 2 wing petals and 2 keel petals. Keel petals are fused. Okay, this vexillary aestivation is characteristic for Fabaceae members. Next is Solanaceae members. 5 petals are there, which shows gamopetalous condition, mostly valvate or twisted. Okay, twisted you will see in Datura. Here in Liliaceae 6 tepals. Perianth has what? Tepals. Like calyx has sepals, corolla petals, and perianth has what? Tepals. Like as such you have 6 tepals, which is petaloid condition in Liliaceae. This shows what? 3 plus 3 arrangement. Okay. This is about inflorescence, flower, calyx and corolla. Any doubts you have in this, you can drop a message in chat box. You are open to ask anything from this. Okay, with respect to subject, we are open to ask anything. Next, andrecium, 10 stamens, which shows diadelphous condition. Diadelphous condition is characteristic of Fabaceae members. Few of them will also show monodelphous condition. Example is Crotalaria. Monodelphous condition means all stamens into a single bunch. That is monodelphous condition. Next, Solanaceae members have 5 stamens, epipetalous condition, which is basifixed, and introdes. This shows what? Dithecous condition. Basifixed, introdes and dithecous condition. Introdes means the pollen grains will open inwards. Okay. Extrodes means the pollen grains will open outwards. Like here if you see, introdes means pollen grains will open through the inner side. Extrodes, pollen grains will open through the external side. Here it is introdes type in Solanum. And 6 stamens 3 plus 3 condition, which shows epiphyllous and dithecous anther. 2 theca present in each lobe is called as dithecous beta. If you take a transverse section of anther, where we will learn it in clear in the sexual reproduction of flowering plants, but for your idea, let me give you a picture, rough picture. Here anther will have 2 lobes beta. 2 lobes. This is lobe 1 and lobe 2. Bilobed. Mostly angiosperms anther will be bilobed condition, and each lobe will have 2 theca. Like here you can see theca 1, theca 2, theca 1 and theca 2 in each lobe. Clear, right? So this is about andrecium. Fine. Both Solanaceae and Liliaceae will show epipetalous and epiphyllous condition. Diadelphous condition is the characteristic of Fabaceae. So this family is showing cohesion, these 2 families adhesion. Remember as such. Next is Gynoecium. Gynoecium is monocarpellary, unilocular, and it follows marginal placentation, where all the ovules are arranged in the ventral suture of the ovary. Okay, this you will see in beans and pea regularly, right? So this follows what placentation? Marginal placentation. How many carpels? Single carpel, that is monocarpellary. And here you see my in Solanaceae members, it is bicarpellary, syncarpous, bilocular, rarely it is unilocular, and this shows axile placentation, where ovules are arranged at the center forming what? Locules or chambers, like this. Okay. Next it is Liliaceae members. In Liliaceae members you can see tricarpellary, syncarpous, trilocular ovary with axile placentation. Okay, tricarpellary, syncarpous, trilocular with axile placentation. This is about Gynoecium. Next is fruit. Fruit, here you can see legume or pod fruit, which is geocarpic, that grows in groundnut. Okay, Arachis hybogia. That type of fruit you can see in Fabaceae members, legume or pod type. Next in Solanaceae, if you see berry or capsule type of fruits. Berry you can see the examples of Solanum and capsicum. Capsule you can take the examples of Datura and Nicotiana. Then Liliaceae members, capsule rarely it is berry type of fruit. Example is asparagus. Okay, rarely it is berry type of fruit. Example is asparagus. Next is seed you see. Seed in Fabaceae members, this is non-endospermic seed, because all the members of Fabaceae are dicots, right? Mostly they are non-endospermic. One to many, they are rich in protein and oil. Best example is Arachis, that is groundnut. Next, Solanaceae, you can see endospermic seeds and many seeds are observed. Liliaceae, endospermic, monocotyledonous seeds, polyembryonic condition is also observed. Example is allium, okay, polyembryonic condition. And last column is about examples, last column is examples. Examples, here you can see P, that is Pisum sativum, Pigeon P, Cajanus cajan, Arachis hypogea, groundnut. Another set of examples are there. I will deliver this in short, this is not available in the slide as of now because of configuration. Till here you remember. Next set you will get it in the short. Here you see Solanum nigrum, Solanum melongena, brinjal, Solanum tuberosum, potato, and tobacco. As such, many plants will be there. Next is Liliaceae, Alum cipa, onion, Alum sativum, garlic, asparagus, aloe vera. These are the examples of Liliaceae. Here for Solanaceae you can also take Belladonna, Ashwagandha, Petunia, fine, chili. These are the examples of Solanaceae members. Here under Fabaceae you can also take Arachis is already there, Sesbania, Trifolium, fine, Molati, which is the medicinal plant. Yeah, this set you take. Next, Liliaceae, most of the examples are given. Alum sativum, lily, aloe vera, asparagus. You can also take Colchicum. Lilium, Gloriosa, asparagus is there, tulip. These are the examples, you can consider it under Liliaceae. Clear, right, ma? So, this is the complete set of distribution, vegetative characteristics and floral characteristics of 3 families. At the end, let us focus on the Brassicaceae. Firstly, the distribution of Brassicaceae. Anyhow, we have already learned the floral diagram, floral formula. Once you look into the theory also, beta. They are widely distributed in temperate regions. Tropical, subtropical, Fabaceae distribution. Remember that. Tropical, subtropical and few of the temperate regions, Solanaceae. Temperate regions, Liliaceae, and here also Brassicaceae members are highly or widely distributed in temperate regions. Most commonly found in North America, Europe and Asia. They are cultivated globally for vegetables, oilseeds, condiments and fodder. Mostly they are mesophytic plants. Here you look into the vegetative characteristics, beta. Habit is mostly herbaceous, annual, biennial. Few of them are shrubs as well. Next, roots, taproot system. Example, radish and turnip. Like storage root modification is observed in Brassicaceae. Storage root modification. Fine. Next, stem, aerial, erect, herbaceous. Sometimes it is branched, glabrous or hairy, depends on the species. Leaves, simple, alternate, exstipulate condition again. Exstipulate condition where stipules are absent. Petiolate, and this shows reticulate venation because most of them are dicots. Next is floral characters, racemose type of inflorescence, same like that of Fabaceae members. Fine. Flower is hypogynous with superior ovary, bracteate or ebracteate, and this is a complete flower again which is bisexual, actinomorphic. Calyx is 4, which is polycephalous, free calyx or free sepals, and this shows imbricate aestivation. And then corolla, 4 petals, which shows polypetalous condition with valvate aestivation. This is also termed as cruciform corolla. Fine ma, cruciform corolla. Next, andrecium shows tetradynamous condition. Tetradynamous condition. This also shows diadynamous condition as well. Diadynamous condition. Okay, with 6 stamens, 4 long and 2 short. Next, gynoecium, if you consider bicarpillary and syncarpous, superior ovary which is unilocular, but it becomes bilocular due to the formation of a false septum or rhipium. Fruit is siliqua and the placentation this shows is marginal placentation. Fine. And seed is non-endospermic, as most of them are what? Dicots. Many seeds are present in a single fruit in Brassicaceae members. This is the floral characters distribution. Now we will solve half a set of morphology previous year questions, and in our next session we will solve the complete set of questions from morphology and taxonomy of angiosperms as well. Here you see beta, first question, drop down your answers, Example of asymmetric flower. Asymmetric flower here is Canna, C. Gulmour, Cassia and P. This shows what? Zygomorphic flower, right? This you see. Next question, assertion reason type of EAPCET 2023. Look at the assertion ma. Eichhornia hydrophyte exhibits epiphyly condition, wrong. This doesn't show any epiphyly condition. Next, pollination occurs either by entomophily or anemophily. Entomophily is insect pollination, anemophily is wind pollination. This is correct, okay. Reason is correct but assertion is wrong. In this case what you have to go, A is false and R is true, option D. This question, statement based beta, statement based. Which of the following statements are correct with respect to the inflorescence in Crotalaria? Crotalaria, which comes under what family? Fabaceae. Shows what type of inflorescence? Racemose inflorescence. When racemose inflorescence is there, the peduncle shows indefinite growth, this is true. Peduncle shows a definite growth, no, definite growth is seen in what? Cymose inflorescence. Next, the flowers are born in the acropetal order in peduncle, yes, in acropetal order only flowers are born in the racemose inflorescence. Flowers are born in the basipetal manner. Basipetal manner you can see it in cymose inflorescence, right ma? So, what two set of statements are correct here? As the correct statements are asked to identify, we have to go with A and C, option B, right, A and C. Look at here. Identify the type of aestivation in which at least one petal completely overlaps the other petal. You see in valvate aestivation, overlapping will not be there, where the whorls will just touch each other. So, we cannot consider valvate aestivation. In twisted aestivation, the petals or sepals will not overlap completely, they overlap in a uniform direction as such, yes or no? So, we cannot consider twisted aestivation also. In imbricated aestivation, if you see, one whorl is completely outside and the other whorl is completely inside, and two worlds will overlap each other like this. Okay. So, you can consider imbricate aestivation where one world which is outside will completely overlap the other world. Okay. In vexillary aestivation, if you see the standard petal which is fusing two wing petals and two keel petals are fused by what? Wing petals. So, here standard petal is completely overlapping the other worlds. So, here you can also consider vexillary aestivation. Here the two options are correct, that is C and D, okay, which is option D. Clear ma? Next, match the following type about inflorescence again. We have covered all the concepts ma. Srividya, good afternoon. Go through the questions ma. You can drop your answers in the chat box. Yeah, look at it. Solitary cyme. Solitary cyme is observed in Solanum, monocacial. No. Solitary cyme is observed in Nerium, monocacial in Solanum, polycacial Datura, dicacial is observed in Apomia, cymeal in Bougainvillea. Clear, right? This will be the right match. Solitary cyme, monocacial, polycacial, dicacial and cymeal. Fine ma. Next question. This is the last question that we are exercising today. Valvate aestivation you can see in Calotropis. Papilionaceous flower, vexillary. Imbricate aestivation, Gilmore. Funnel shaped corolla you can see in Datura. So, what will be the right set ma? A is 3, B is 4. Yeah, A is 3, B 4, C 1, sorry C2, where papilionaceous flower will show what? Vexillary aestivation, and then D, that is imbricate flower, will example is what? Gilmore. This is the right set of match. So, yes, with this we will end today's session. In our next session, we will finish the complete EAPCET PYQs of morphology of flowering plants and taxonomy of angiosperm. So, next session is very important beta. Stay tuned for the next session. Revise the complete chapter of morphology of flowering plants. Any doubts that you have, you have the complete liberty on dropping your doubts in the chat box here, where I will be personally answering your doubt sessions. Okay, so that's all for today's session, and thank you.